In the next few examples, we're going to focus our hypothesis testing on strictly proportions. So on the screen is a reminder of the variables that we've been using for this parameter. Remember that we defined x as the number of successes and n we've been using for the number of outcomes. It would be our sample size. Lowercase p has been representing the population proportion, whereas p hat has represented our sample proportion of x over n. We're going to start calling this, or you may see this, also defined as observed statistic. So when we say observed statistic, what we're talking about is our sample of p hat. And then alpha, we've seen this before, but we're going to officially define it as our significance level. We assume alpha is 0.05 unless otherwise stated. Now, just as a reminder, remember that a p-value, which we saw defined in a previous video, is not the same thing as lowercase p. Lowercase p is our population proportion. The p-value is the probability of getting our test statistic or our observed statistic, or p hat. It's the probability of getting our sample as at least as extreme as one representing the sample data. So just remember and don't confuse, because a lot of people get confused between all of these P's. Now, we've seen already the steps for hypothesis testing, but I'm going to add just a little bit to it. And what I've added to the previous 5 steps is shown here in italics. So we know already that we've got to determine our parameter, verify the normal distribution, make a statement regarding the population, which becomes our null and our alternative statements. You collect the evidence, in other words, you sample, and then we know we analyze the data. Now, how do I go about analyzing that data? That's what we're adding. We will be doing it here by finding our p-value. You might also see it by using a confidence interval. The p-value method that we are going to use asks us to compare the p-value, that probability of getting our sample, with what's been defined as alpha. And when I do that, when the p-value is greater than alpha, we're going to do what's called fail to reject the null. This will become a little bit clearer when we actually perform this process, but that's what we will be concluding. If the p-value is greater than or equal to alpha, we fail to reject the null. When the p-value is less than alpha, we reject the null. So make sure that you have these two concepts here. P-value greater than alpha, fail to reject. P-value less than alpha, reject. Now, if you were doing a confidence interval, you would just need to make sure that your null was actually inside the interval you created. And the reason I put these two possible ways to analyze a hypothesis test here for you to see is because they're the two most common ways you might see them if you were looking at an actual study that's been published. And then once we have analyzed the plausibility of our sample, that's when you're able to finally make a conclusion. So although you've seen 1 through 5 previously, I want you to add the remaining information here to what you were already making a list of as far as those steps for hypothesis testing.